Welcome to lesson 58, where we're going to continue practicing combining like terms and using the commutative property. So here are the things you're going to watch me model that you'll practice doing before your exit ticket. 1, successfully identifying when terms are like or not like. So this is just like in the last lesson. 2, that we can correctly combine like terms in an expression using the commutative property. So we're going to look for that as well. And 3, that we can identify algebraic expressions using our order of operations. So let's jump into our first problem. Simplify the expression 4x squared plus 7 plus 3x minus 1 plus 2x. What are the like terms you notice in the expression, and how do you know they are like terms? So pretty much they're asking us to combine the terms to simplify the expression. And the only information we have is that long expression with 5 terms. So here's our plan. We're going to identify the like terms and annotate the problem. And then we're going to rearrange the expression so the like terms are next to each other. And that is when we use the commutative property. And that pretty much means just how we reorder it without changing the outcome of the problem. So that's what we're going to be doing there. And finally, we're going to combine like terms by adding the ones that are the same. And if we need to, we're going to use order of operations to simplify the expression. All right, so hit pause so you can jot this down into your notes. We're going to look at a more complicated expression. 4x squared plus 7 plus 3x minus 1 plus 2x. And we're going to follow our same 3 steps, identifying, rearranging, and combining like terms. So the first part is pretty easy because we're just going to identify our constant terms. It's easy, just look for numbers. But before I look at the next set, I'm going to look at the variables. Notice we have x squared and just x. And these are not the same, math marbles. I'm going to prove why. I'm going to use actually these two, for example, 4x squared and 2x. When I have 2 x's, I know this means I have 2 sets of the same number. I'm going to ignore even just a 4 for a second, but when I have x to the second power, I know that I have x times x. So these are 2 very, very different things happening right here, math marbles. There's a big difference between adding 2 x's together, saying I have 2x, and multiplying them together. Pretend that x was equal to 5. There is a big difference between 5 times 5 and 5 plus 5. And because of that difference, because exponents are different than just having the x term, we cannot call them like terms. So when I do this problem, I'm going to have these as the same, 3x and 2x, but x squared, 4x squared is not the same. It has to be different. So I now have 3 different sets of like terms. So let's rearrange them. Let's put the things together that are the same. I'm going to leave the 4x squared by itself. And let's put the x's together. And finally, our constant numbers. So we've identified our 3 common sets. We put the things that are the same next to each other, and now it's time to combine or to add together like terms to turn 2 terms into 1 term. And so the first one is easy. 4x squared, still 1 term. I'll leave it blue just for consistency's sake. And 3x plus 2x. Well, I have 3 x's and I add another 2 x's. Now I have altogether 5x. So I've simplified this to 1 term, which is what we want. And now 7 minus 1. So positive 7 plus a negative 1. I have positive 6. And I know how I actually was intentional in saying that. I actually said positive 7 plus negative 1. Even though we've read this as 7 minus 1. So I'm saying that intentionally because when we combine, we're adding them together. And I know I still have a positive 6. All right, and we've simplified this expression from 5 terms down to 3. I can't go any further because our terms are different. My x is to a different power. I have x's here, and I have my constants here. So constants, x, and x to a different power. And when you get older, we're going to call this degree. Our x is to a different degree than the other. So hit pause so you can jot this one down into your notes. Because now you know how to take even more complicated expressions and simplify them by combining like terms. We're going to use raised for this next one because it's multiple choice. What is the most simplified version of the expression 3x plus 14 plus 3x plus 10? And they gave us 3 different options. So this is obviously an EE problem. Our key information, we have our expression 3x plus 14 plus 3x plus 10. So that's our key information, and we know that we're going to combine our like term. So what do we know we're going to do? What are we going to see? Let's identify. Let's rearrange. And then we're going to combine our like terms. And hopefully this will help us to eliminate some answers. Well, actually, I'm pretty sure just eliminating, just taking a look and scanning, we can probably do some eliminating. Like I'm looking at A, and I'm noticing that they did not combine all of their constant terms. So I can eliminate A. Our constants are not combined. And I'm pretty sure D is also another one we can eliminate because we cannot. We have constants and we have x's. We have a variable x. So there should be at least 2 terms here. So I'm going to eliminate A and D right off the bat because we shouldn't have 1 term and we definitely shouldn't have multiple constants. Okay? Leaves us with B and C. Let's go through the work and see which one is the correct answer. One of them is definitely a distractor. And let's try to identify it. So we can look at it and let's identify our constants. Nice and easy. And our variables, 3x and 3x. So they're the same degree, so they're the same. We'll rearrange 3x plus 3x plus 14 plus 10. So these are the same, and these are the same. All right, and now let's combine our like terms, add them together. 3x's plus 3x's, that will give us 6x, so we're down to 1 term. And 14 plus 10, combine them together, 14 plus 10 gives us 24. So we're now down to just 2 terms, which makes sense. Just by scanning it, we knew it was going to be 2 terms because we had constants and we had x's. So now let's take a look and see what we notice. We have 24 plus 6x. I see the 6x and I see the 24, so B looks like it's the correct one. And C has a 9x plus 24. So although the 24 is correct, 9 is incorrect. So think for a minute, why would someone have gotten 9? How can I justify it? They probably did 3 times 3. So instead of combining those like terms, they may have multiplied. That is incorrect. So hit pause so you can jot this down. Notice how we can show all our thinking on the page and we can justify our elimination of all 3 different options. Great job today, Math Marbles. We're going to get more practice with this. I will see you in the next lesson. Take care.